Welcome back to the Water Slash series. This project is a full breakdown of creating one stylized VFX effect from scratch, from the first mesh and silhouette through the blockout all the way to the final polished result. In the previous episodes, we modeled the slash mesh, shaped the plow and started building the blockout. Last time, in part 1 of the blockout, we created the core motion, the outer layers, the beam, flash and all the particles that define the overall shape of the effect. This video is part 2, a continuation of the blockout process. Here we refine the animation, align both sword strikes, build a 2-strike sequence, adjust emitter placements and set up cameras so the effect reads clearly from every angle. If you are following the whole series, this episode connects all the previous pieces together. And if you are joining for the first time, this part gives you a full look into the real VFX creation process, the problem solving, the fixes, the timing adjustments and the decisions that shape the final look. Let's jump in. The second part begins with another pass over the effect, checking how everything moves together and refining the pieces that feel off. Some of the particle curves get reshaped here and a bit of noise is added to make their motion less predictable and more organic. At this moment it becomes clear that something is wrong with the animation. The character isn't standing on the ground. The reason is simple. One animation was exported on Mixamo's Xbot skeleton, while the second one was exported on the character holding the sword. Unity treats these as completely different rigs, so their position doesn't match. Sources Unity uses humanoid rig retargeting. Inside the animation import settings, switching rig animation type humanoid and creating an avatar from the model allows Unity to map the bones correctly. The same needs to be done for the second animation, except this time the avatar should be copied from the main character. This ensures both clips share the same skeletal structure. Since the rigs didn't match, the most reliable solution is to go back to Mixamo and re-export everything on the same skeleton. For consistency, the Xbot skeleton is used for all animations. Once the new clip is imported back into Unity and assigned to the character, all warnings disappear, the animations fully agree with each other. The corrected animation is inserted into the timeline and the avatar is assigned to the character in the scene, so Unity knows which skeleton to use. Setting the avatar reveals another issue. The idle animation breaks. After checking the imported clips, it turns out the animation previously renamed as idle wasn't an idle at all. It was actually an early slowdown slash from the first video. So the clip gets renamed properly, the actual idle animation is located, set to humanoid and retargeted just like the others. Once all clips have the right names and the right avatars assigned, the proper idle and the proper slash animations can finally be placed into the timeline without problems. With the retargeting fixed, the character now stands on the ground, doesn't float in the air, and the transition behaves as expected. The next step is adjusting the position of the VFX so it aligns perfectly with the corrected animations. Once the particle system is placed in its new position, the rest of the subsystems also need to be adjusted. The impact effect gets rotated to align with the direction of the sword's wing, and the same correction is applied to the impact particles so their motion follows the strike correctly. At this point it becomes clear that the particles are traveling in the wrong direction. So the emitters get flipped by 180 degrees, allowing the particles to follow the sword instead of moving against it. Both approaches have their own logic, but here the decision is based purely on visual appeal. The small contour particles get removed as well, since they no longer fit the motion language of the effect. A new issue shows up with the beam. Its spawn point changes every time. And this happens because the cone radius wasn't set to 0, meaning the particles appears anywhere along the cone instead of at a fixed point. Resetting the emitter's transform and setting the cone radius to 0 solves the problem, and the beam now spawns exactly where it should. With the beam fixed, its position gets copied directly into the flash system. This keeps both elements perfectly aligned and ensures the impact happens at a single clear point. To preview the animation in a continuous loop, the timeline object needs to be switched to wrap mode loop. This makes iteration faster and helps see how the effect behaves over time. Next, the sparks following the slash. Not the impact part, but the ones trailing along the blade get some refinement. Their quantity now varies along the motion. Instead of a constant spawn rate, a curve is used. This creates fewer particles at the start and more during the main arc. Additional tweaks include experimenting with noise, directional velocity on the y-axis, and various parameters to make the trail feel more dynamic and alive. Once the motion feels right, the animation tracks get cleaned up. Unused animations are removed and the remaining ones are kept with the clear and correct naming, ready for the next phase of the blockout. The idea now is to expand the effect into a small sequence instead of a single strike. So the next step is heading back to Mixamo to find the second fork swing animation, ideally one that comes from the opposite side, so the slash can be seen from both angles. The new animation goes through the same setup process as the previous ones: humanoid import, avatar assignment, naming and timing adjustments. Once everything is ready, the clip gets added to the timeline and the second strike. Here comes a bit of experimentation. At first, the plan was to shorten the animation and remove part of the anticipation, since the character was winding up a bit too long and the sequence felt slower than desired. But trimming the beginning makes the movement jittery and nervous, not the kind of energy this effect needs. So the full anticipation stays, giving the strike a natural, confident acceleration instead of a twitchy snap. To play the same slash effect during both strikes, the VFX object needs to become a prefab. This way, editing the effect in one place automatically updates every instance. A new folder for prefab is created, the slash system in the scene gets a clear name and is dragged into the folder to become a reusable prefab. An instance of the prefab is placed into the scene and aligned with the second sword swing, both in timing and inward position. Since the slash is now viewed from the opposite direction, this pass helps refine the emitter placement and make the effect feels consistent from both sides. Later, all position changes will be applied back to the prefab, so everything stays synchronized. And with the two-strike sequence setup, the next stage is camera work. Framing the motion, finding the strongest angles, and preparing the effects for the final render. With the full two-strike sequence in place, the next step is to rework the camera so the effect plays from its strongest angle. While adjusting the view, the slash material also gets switched to two-sided, allowing both the front and back faces to be visible even when the camera moves behind the character. The process starts inside the scene view. The angle is roughly positioned there first. Once the framing looks right, the game camera is aligned to the scene view using game object aligned with view. After that, a few final adjustments are made directly in the game view until the composition feels solid. As the camera moves from different sides, new details become visible, so the emitters get small positional tweaks as well. Some elements appear slightly off from one angle but perfect from another, and that's normal. This stage is a blend of finding the right camera angles and nudging the emitters to match the motion from every view. One more important detail is added here. The largest, most transparent outer mesh, the one that rotates against the main slash, gets additional scale animation. It gradually grows over its lifetime, creating a soft residual energy effect that expands outwards while fading away. With a gentle shader, this layer gives the slash a beautiful outer glow and enhances the feeling of flowing power. With all cameras placed in their new position and the last adjustment applied, the entire sequence is reviewed from start to finish. And that marks the end of the blockout phase. And this wraps up part 2 of the water/blockout. In this episode we refined the animation, aligned both sword strikes, built the 2-strike sequence, polished the emitter placement, adjusted the particles and set up the cameras so the slash looks clean from every angle. Together with part 1, this completes the entire blockout stage. Now the effect has its shape, timing, rhythm and the overall motion language, the foundation that everything else will be built on. In the next episode we'll move into the next major phase. Most likely that will be textures, although depending on how the effect evolves, we might start shaping the shader first. We'll see what feels right when we get there. If you found this breakdown helpful, or if you enjoyed this open process-focused format, feel free to leave a comment. Your feedback really helps me shape this series as it grows. Thank you for watching, and I'll see you in the next part. Bye bye.